Hello students, I hope you're doing well. Let's look at some factoring today. This is from the 9th unit of polynomials. So factoring is really important for any student who is doing pre-cal or beyond. You probably learned this in your algebra classes earlier. So this is just a quick refresher. So let's quickly look at what it really means to factor. Suppose I have 2x times x minus 4. I'm just taking this as an example. What would you do when you have to find the product, right? You would distribute 2x over these two terms. So it would be 2x times x, which is 2x squared, and 2x times negative 4, which is negative 8x, right? Alright, so remember this. Suppose you didn't see this at all, right? And you're asked to factor this guy, right? How would you factor, right? So that's the question here. So you would actually do the opposite of the multiplication, right? You have to actually look at what is common between these two terms, and in that we have to look at greatest common factor. So here we have 2 everywhere because 2 goes in 8, and there is x here and here, so you can as well remove 2x from each term. When I say actually remove, we are doing opposite of what we just did before right here, right? So let me write this again just for a reference. Right, this was our journey from here to here. Now we have to go back to this. So you have multiplied 2x with x to get to 2x squared. So now we have to do the opposite, meaning we are dividing. So 2x squared, this 2x squared divided by 2x. What would we get? It's just x. So x comes here, and 8x divided by 2x. So each term should be divided. So that would be 4. Right? So that's how we get back to 2x times x minus 4. So that's the concept of factoring. Factoring is the reverse process of multiplying. Right? So with that in mind, we can actually find the greatest common, factor all these. The whole factoring is running around reverse of multiplying, okay? So here the greatest common factor is 6, so I would pull that out. 12 divided by 6 is 2, so it's 2k minus 18 divided by 6 is 3. Alright, so that's how it goes. So sometimes you'll have more than one term and also more than one variable to factor out, including the numbers. So here I have, there is no common factor with respect to the numbers, but you see that a and b is everywhere. So you factor out a times b. So when you divide a and b here, you're just left with 3b minus 5a from the second term and just 8 from the last term. Okay, so this is the GCF. So the thumb rule is for any factoring, thumb rule is find the GCF. Just look for greatest common factor before you factor. Okay. All right. So now let's move on to this situation. So if I have, again, a small little intro into this. If I have let's say x plus 9 times x plus 5, and you have to multiply it and use your favorite method to multiply. You can use FOIL or use the box multiplication. X plus 9 times x plus 5. So this is x squared, this is 5x, this is 9x, and this is 14. So you see that this 9 times 5 is 45, which we see here and here. And 9x plus 5x is 14x, isn't it? So we are in fact getting this trinomial by multiplying these two. But that was not given to us. So how would we find these factors from here? So that's the goal. So what would we do? If you actually see 9 times 5, 45 is the product of these two roots, isn't it? So 45, usually the last term, I should say 8 times c. Suppose there is a here, then the situation will be, this is the situation where a is 1, where the leading term is just 1. But here, if it is not 1, then somewhat like this, we'll see in the other cases right now. So 45 is a product of 9 and 5. And where this 14 came? This 14 came from 9 plus 5. So if we actually see this, you can actually put this as an X method, which we followed. Many people have different ways of doing this, okay? I'm choosing this way because our school has been following this. And B at the bottom. So 8 times C, A is happening to be 1 in this case, okay? But normally if it is not 1, it'll work. So that's the reason why I make it a habit to write A times C on the top and B at the bottom. So here A times C is 45. 1 times 45 is 45. And the middle term B is down here. So in other words, we are looking for two factors of 45 that add up to 14, right? And the immediate thing that comes to our mind is 9 times 5. 9 times 5 is 45. Normally it's a little complicated. If it is a little complicated, there are ways around how to find factors. But right now it's pretty straightforward. 9 times 5 is 45 and 9 plus 5 is 14. And all you have to do is take the positive signs and just write the factors with x plus 9 and x plus 5. That's it. So that's how you split it. In a regular process, you would write this as x squared plus 9x plus 4x plus 45 and so on. This is not needed really. I mean, you use a grouping method from here. This is the classic way of doing it, but this is a shortcut. Shortcut with an idea that 9 times 5 is a product of the roots and 9 plus 5 is the sum of the roots. Alright. Likewise, pause and play. Just pause and try to do the sixth one by yourself. But eventually, you should get to the point where you are not requiring to even write this on paper like the X method. All that should happen in your head. Okay, so and you will get there. It comes with practice, and just practice and practice. That's the only way. And also having a good memory of multiplication facts really helps. So 26 is 13 times 2, but this happens to be a negative number. So if we make both negative, then two negative numbers add to negative 15, and two negative numbers, product of them would be a positive number. So this works perfect. So our answer would be W minus 13 and W minus 2. Alright. And likewise, here C plus 8 and C minus 6. That's it. So you really don't have to do this, but once you find that, okay, 48 is 6 times 8 and 8 minus 6 is 2, you really don't have to do the X method. Okay, I'll leave the 8th one to you. Coming to 9th and 10th, they are a little special because they're special products. You can do the X method for this, sure. I'm not stopping you. And you'll see that both are the same roots, and you'll write it as a plus 6 times a plus 6. And so it is a plus 6 squared. But there is another neat way of doing it. So let me erase this so I can make space. Here, this is a special product, meaning if you see that if you actually multiply a plus 6 times a plus 6, right? I'm using the box method. You can foil it too. If you actually multiply, you will see that this 12a is split into two equal parts, 6a and 6a. So it means that a from here and 36 is a perfect square. You have to see if this third term is a perfect square, and it is. So it is 6 squared. This is 6 squared. So take the 6 from there, a from here, and just check if the middle term is twice of a times 6. Is it? Yes, it is. So because 2 times 6 is 12. So you can as well write this straightly as 8 plus 6 squared. Okay? Straight away it is a plus 6 squared. So you really didn't have to do the x method at all. So like here, you have n from here and 1 from here, because 1 squared is 1, isn't it? 1 is a perfect square. So 1 from there, and just check if the middle term is twice of the first term and the second term. And yes, it is. 2 times n times 1 is 2. And whatever is the sign here, you will carry it. So it is n minus 1 squared. You can check with x method if you want, and that's the answer. This is a special product. A plus b squared is a squared plus 2ab plus b squared. Okay, now let's quickly go to the next part here. If you can actually find the GCF, first find it. I was telling you the thumb rule. Just if you see a common factor, go ahead and pull it out, right? And this can be easily done with the x method. It is times, that's it. Okay, so likewise, I want you to do this. Let's go ahead and do the actual trinomials where a is greater than 1. So what should you do? Now our thing comes up again. So here you must do a time the x method with a times c on the top, b at the bottom. A times c is 36 and b is negative 15. So here the factors would be 12 and 3, right? 12 times 3 is 36, but this is negative, so make them negative. But you have a other than 1, okay? If a is other than 1, sometimes it's negative also. So divide each of these by that a, okay? And when you divide, why should we do that? If I just straight out say x minus 12 times x minus 3, for example, then if you multiply them back, you should be getting 2x squared, but we are not getting 2x squared, but just x squared. So that's the reason why you have to take care of that 2 here. So divide by 2 each of them and reduce them to fractions. This is a negative 6 and this remains because it doesn't get reduced. So straight out write negative 6 as x minus 6 and negative 3 halves as, now look at the denominator, it's 2 times x, so attach the x to this, and minus 3 is from the numerator. So 2x minus 3 from there. So x minus 6 times 2x minus 3 is your answer. Okay, let's do quickly one more over here. Okay, here if you see, you will get 5 times 48 as a big number, and I'll make it a little easy for you. So the factors here are negative 30 and 8, but you have to divide by 5 and you will get negative 6 here. So this is p minus 6 times 5p plus 8. Okay, so that's the deal with anything other than 1. Okay, so I'll see you next time. I have a video for difference of squares already. So this is about factoring, and please do try these methods, and in the class I can teach you the calculator trick to do the factoring for bigger numbers. Alright, thank you for watching. I'll see you next time.